And now for the sound and air example. Again, another social distancing one. So this time, Governor DeWine is social distancing during one of his daily press conferences with Dr. Amy Acton. When they are standing 1.8 to 88 meters apart, which we now know is our 6 feet minimum, it will take 0.00525 seconds for his question to reach her. The question is, how hot is the room? Alrighty dighty. So obviously, when we're trying to find how hot is the room, we're going to want to use our equation for the velocity of sound and air as being the 343 meters per second plus 0.6 meters per second per degree Celsius times the temperature minus 20 degrees Celsius. Okay. So all we need to do to figure out the temperature is to find the velocity. So, but you're saying to yourself, I don't have my frequency, I don't have a wavelength, all I have is a distance and a time. And then it occurs to you that back in August, we learned that velocity is simply the change in position over time, or the displacement over the time, which would be the distance between Governor DeWine and Dr. Acton. So this means that we can determine the velocity by taking our socially distant 1.8288 meters divided by our time of 0.00525 seconds, which would be the equivalent of 5.25 milliseconds, which quite honestly, realistically, totally quick time, giving us a velocity of, punchy on my calculator, hold on, let me do that, 8 divided by 0.00525, and we get, you can almost see it, 348.342857. So 348.342857, on and on and on. And then we can use that number for our velocity to figure out the temperature. So I'm going to do a little rearranging first, which is to say, take my velocity minus 343, which would equal my 0.6 times the temperature minus 20, or take my velocity minus 343, divide the whole thing by 0.6, and then I would be left with t minus 20 on the other side. So I can move the 20 over to the left-hand side by adding it to both sides, which gives me my temperature would be equal to the velocity minus 343 divided by 0.6, that whole quantity plus 20, or my temperature is 348.342857, on and on and on, minus 343, that quantity divided by 0.6, that entire quantity plus 20. So again, handy dandy calculator. So I am going to open my, you know what, I'm just going to make a fraction and take my previous answer, minus 343, divide that whole thing by 0.6, and add 20 to it, which would give me a temperature of 28.9 degrees Celsius, which is a little bit higher than 85 degrees Fahrenheit.